Good afternoon, everyone. My name is Felix Koshy. I am from India. I am currently working with HPCL Mumbai Refinery. I am working in operation departments. And today, my main subject is to bring your attention to one innovation we have done in our running plant, catalytic reforming unit, which could help us to enhance our capacity and energy. And this enhanced energy help us to improve the total profitability of the plant. And since all of you are not much aware about this company, I will give a brief introduction. So we are having two major refineries across east as well as west coast of India. One is in Mumbai. That refinery is having a capacity of around 10 million metric ton per annum. And we are having another Vizag refinery, which is having around 15 metric ton per annum. These data are last year updated consolidated data. And apart from that, we are having some joint venture refinery in North India as well as in central part of India. In the marketing side, we are having a lot of depot marketing petrol stations, and some R&D side, we are having some development and patent development issues handling teams that is located in South India, Bangalore. And for further details, you can visit the HindustanPetroleum.com site, since it will be very comprehensive if you are going through this all through the slides. Okay. So this is the core topic I am going to present today. The burner tip modification in HPCL Mumbai Refinery catalytic reforming unit. So I will give you an introduction why we had to check for an option to go for a burner tip modification. Our catalytic reforming unit that got revamped recently 3 years ago for enhancing the capacity and to improve the energy efficiency of the plant. And within the same space, we had to achieve this revamp. So these are the points which I am going to cover. Earlier, we had a plant with 90 meter cube per hour capacity for catalytic reforming unit. Around 30% of the capacity got enhanced in the revamp. Ultimately, the feed rate raised up to 123 meter cube per hour. The targets have been already discussed, and the unit is actually licensed by the process licensor MSGOPE, Universal Oil Products, based in US. The refinery catalytic reforming units are having predominantly endothermic reactions. These endothermic reactions require a lot of heat addition, since to make up the heat loss through the system, we need to incorporate a lot of heaters. So a basic configuration, it may not be a typical one in all the refineries. A basic configuration will be like this. So in this configuration, you can see 4 reactors in which the reactions are happening. And primarily, the naphtha for this reaction is being taken up from the naphtha hydrotreating unit, and the naphtha gets preheated. Naphtha is a hydrocarbon stream that is ranging from C6 to C6 will be in minor quantity in heavy naphtha, C6 to C10. C7 to C10 is the main component, and C6 is the impurity. Anyway, the feed gets preheated and then it gets vaporized completely in heaters and it goes into the reactor. Once it starts reacting, due to the endothermic nature of the reaction, the temperature drops drastically in the reactor, and to make up that heat, We will put fire in the heaters. The media of firing is fuel gas in our case. So it is bottom fired heater and it gets heated up again to the same temperature. Typically, it operates around 530 degrees Celsius and the reactor pressures will be around 4 to 5 kilogram per centimeter square gauge. Once the reaction is completed, it will get separated after giving the heat to the feed incoming, and the gas composition will be compressed to hydrogen-rich stream. At various stages, we will compress it and refrigerate it to get the maximum volumetric yield, and the liquid part goes into the separation and subsequently to the stabilization sections. So it is all about the basic process flow diagram. I will just give you an introduction about how the flow actually happens in a reactor. The feed is coming from the furnace to the reactor where the catalyst is flowing in gravity in a very small pace to the downwards direction, while the catalyst faces the feed in a cross current pattern and the product gases comes out of the reactor to the next furnace. So this repeats for bigger conversions. We will be having a number of other reactors. In our case, there are 4 reactors. And first reactor is called the charge heater because it is the first heater. This will be having a moderate load, and the first heater and first reactor will give maximum endothermicity, and then because of this thing, the first interheater, the configure, I will just check it out with the PFT. The second heater will be the interheater 1. This heater will be having the maximum load. The numbers are given as 2001, 2, 3, 4. The interheater 1 will be having the maximum heat load just because of the fact that the first reactor is having the maximum exothermicity. So this was the comparison of design data of pre-revamp and post-revamp configuration. And you can see these all are theoretical data. But when we implemented the revamp, we faced many issues. Why there is a problem when we happen to do the revamp? Because in the practical case, the equipment was already old. There may be a lot of limitations to achieve the theoretical design cases, and intended design, it cannot be considered as a design failure. It varies to case dependency to the each heaters and specific locations. And the problem we faced was in all interheaters. Specifically in interheater 1, we had higher bridge wall temperature whenever we were going to increase the feed or reaction temperature. In either way, we can increase the feed rate or we can increase the reaction temperature to get profitable products in terms of quality or quantity. So the bridge wall temperature is arch temperature only. In furnace, there are 2 sections primarily, that is radiation and as well as convection section. The radiation section heat transfer is happening to the process side stream, and this heater was having this flame flickering issue and flame pattern flickering and abnormal arch temperature issues. This was due to the higher flame height. This flame height led to the higher arch temperature, and this led to higher bridge wall temperature, and thus we faced the issue. In order to address this issue online, there were other solutions also to address this. We can add one furnace box or some other kind of burner modification we could be doing in the offline, but in a running plan, we cannot take any of these kinds of projects. So the only option left was to identify the available technological feasibility to do some modification in the burner. So we identified that there are 4 burner tips in one burner, and there are 11 burners in this interheater 1. So we modified the burner tip angle from 90 degree to 70 degree. So we have slanted the flame towards the center of the burner by 20 degrees. By reducing the flame angle, by burner tip reduction, flame angle also got reduced. The flame impingement issue got resolved to some extent. It is not a permanent solution. Let me tell you that this is an online solution. This is not a permanent solution. We could get out of this problem to around 20% of the total comparative issue in this concern. So earlier, I have just, due to some proprietary issues, I have not shown the original thematic pictures of these things. This is almost 20 degrees away from that pot sizes which you can see in the pictures. The 4 burners are cyclic, are in round pattern. So the tip will be facing the center of the burner, and thus the flame got away from the arch by a little, and the arch temperature got reduced. The differential temperature across each of the furnace is actually a function of the capacity of that heater. We can see the pre-modification and post-modification data clearly indicates that around 10 to 15 degree clear margin we got by increasing this modified burner tip, by decreasing the modified burner tip angle. So other duty wise, by converting this duty, we have got around 10% of the additional heat duty, and this was a really good achievement for a very small payback. This payback was only hardly less than 30 days. In fact, this modification we have done with almost 700 euros only, and we got around 100,000 euros in return almost in 1 year. So it is number of days in payback is hardly 20 days or so. The primary achievement was due to the flame height reduction, as I have already explained. 6.5 to 3.5 meter height reduction was there, and this all are the allied benefits we got. The bridge wall temperature got reduced, and this reduced bridge wall temperature brought our stability and reliability of the furnaces. So APC also incorporated along these changes advanced process control systems by Honeywell. This was also helped to optimize the furnace further, and this helped us to have a lot of benefit in our profitability. The y-axis shows the N+2A. N+2A is essentially meaning naphthalene plus aromatics, 2 into aromatics in the feed. N+2A will typically denotes the catalyst, the feed easiness to become reformate product. Reformate is having a very high octane number. The feed quality will determine the efficiency, how effectively it can get reformed. So N+2A is that number which will tell us whether it is a good feed for the reformer or a bad feed. So I have selected this data in such a way that we are having almost constant N+2A values for the pre as well as post modification period to get accurate results. There was around 0.7 to 0.8 research octane number improvement in the reformate stream. This corresponds to almost 100,000 euros in 1 year. So this page already contains almost all the summary of these changes. Even a small change of burner tip modification in a furnace in a running plant could fetch us a lot of benefits. The reliability improved, the process got optimized, the energy efficiency target was achieved, and it in turn turned into a profitability enhancement activity for the refinery. All these things have been done in in-house way within a short time span also. And with the benefit of this interheater 1 exercise, we have extended this to the other 2 furnaces also. There are 3 interheater furnaces, and in total, we could completely perform the performance guarantee, and guarantees have been achieved. And that's all from my part. And anybody who is having any particular interest in this topic may be always welcome to ask any questions, not even at that time. So hope at least everybody's mind is not as blank as this sheet or mine. So
Thank you.
I'm always open for any questions.